So problem 3, you have to draw a picture to describe the situation first. Number 3, the student can see a water tower from the closest point of the soccer field at San Lobos High School. The edge of the soccer field is about 110 feet from the water tower, and the water tower stands at a height of 32.5 feet. What is the angle of elevation if the eye level of the student viewing the tower from the edge of the soccer field is 6 feet above the ground, round to the nearest tenth of a degree? Now, the trick with these problems is always coming up with a picture, and then you're probably pretty good at figuring out which trig ratio or what right triangle rule to use to find the missing information. But drawing the picture can be quite a challenge. So I'm going to take this apart and draw it piece by piece. And we'll start with the student can see a water tower from the closest point of a soccer field. So here's the student down at the soccer field, that little dot. And the water tower is someplace over on this side. There's the water tower. And we're also going to have to think about the eye level of the student. So here's the student, and here's their eye level. So the tower is going to be a little taller than what I drew. I'll make that a little bigger. Now let's see, what else do we have? The edge of the soccer field is about 110 feet from the water tower. So here the student is at the edge of the soccer field. And the water tower stands at a height of 32.5 feet. And the student's eye level is a pretty tall student. It's about 6 feet above the ground. So between here and here is 6 feet. So when we create our right triangle, which we're going to do next, we're going to take 32.5 feet, which is the distance from the top to the bottom of that water tower, and subtract 5 from it. Subtract 6 from that, the height of the student. 32.5 minus 6 is going to be 26.5. So this is actually the triangle that we're going to be looking at, this triangle right here. 26.5 feet by 110 feet, that right triangle. All right, and we want to know what the angle of elevation is. So what is the angle that the student's eyes are making when they first look straight across the field and then up at the top of the tower and round to the nearest tenth of a degree? I'm going to redraw that triangle a little bit, just the part that we're looking at, so we can identify which trig ratio we might want to use. I'm going to mark the angle of elevation. That's the one we're going to be looking for. We know that this bottom piece is 110 feet, and the side, that leg, is 26.5. And looks to me like we have adjacent and opposite sides of our right triangle. So I'm going to use tangent. Here's my ratio. Tangent of the angle we're looking for is equal to the opposite over the adjacent side. So the opposite is 26.5 feet, and the adjacent side is 110 feet. Because I'm looking for an angle, I need to use the inverse relationship. So I'm either going to use a calculator, or I'm going to look on my table and find the value of the inverse tan of 26.5 divided by 110. I'm going to pause the recording here for a minute so I can find my trig sheet, and then I'll give you the answer. Alright, so hopefully you have your calculator ready to go. I've got a scientific one that I'm going to use, and I'm going to be using the inverse function. So on my calculator, on my computer, I have to hit the inverse button. If you're using a graphing calculator or a scientific calculator, you may need to use the second button, or the second function key, because you want to find where the inverse tan is, and that would be this button right here. So let me just clear this, and I want to find the inverse tan of 26.5 divided by 110. So 26.5, oops, missed the decimal point there, 26.5, divide that by 110, and then I'll find out what that decimal is. Here is the inverse tangent of that, 13.5. So looks to me like it's 13.5 feet, or 13.5 degrees, round to the nearest tenth. So the answer is 13, I almost have no space here, 13.5 degrees. There is my answer. Maybe I should highlight that so I can find it. Yay!